Alright class, this is Luke and Spencer's culminating task, and this is our question. We were given the inequality x plus 2 over x minus 5 is greater than 3 over 5. The solution to this inequality should be the intervals that satisfy this inequality. So the steps to solve this will be, first, to rearrange to get one rational function is greater than 0. So one is greater than the other. Secondly, we will identify the intervals by finding the vertical asymptote and the x-intercept. Third, we will create an interval chart, which we will go into more depth later on. Fourth, we will find solutions to our interval chart. Lastly, we will state the solutions that we got. And to check, to make sure we did everything correctly, we will check our solution to a graph.
Okay, so we're going to jump right in here. So we were given the problem x plus 2 over x minus 5 is greater than 3 over 5. And to get this to be one rational function, we have to bring this guy over, as you can see I did here. So we bring it over, it becomes negative. So x plus 2 over x minus 5 minus 3/5. So now we have to get the same base, because to subtract we need the same base. So basically you combine these two terms and get 5 times x minus 5 on the bottom, but then you also need to do the same things to the top. So we bring this 5 up and multiply it by x plus 2, and this x minus 5 multiply it by 3, as you can see is written here. And from there we expand. So we basically use the distributive property to expand it. So 5x, 5 times 2 is 10, 3 times x, 3x, 3 times negative 5, negative 15. So now we apply this negative sign and simplify. We collect like terms. So 5x minus 3x will lead to 2x. The 10 minus 15, so this will become positive, so plus 15. 10 plus 15 is 25. And so the final rational function will be 2x plus 25 over 5 times x minus 5 is greater than 0. And this is going to be what we're going to find the intervals for. So I have prepared another note. The vertical asymptote will be the bottom set to 0. So x minus 5, you bring the 5 over to this side. It's negative, so it becomes positive. And the vertical asymptote will be x equals 5. The x-intercept is the top equal to 0, so 2x plus 25. Bring the 25 over, becomes negative. And then bring the 2 over and divide by 2. It will be negative 25 over 2, but because decimals are better, we're going to switch it to negative 12.5. And so looking at these intervals, it will be negative 12.5 and 5. So we have those laid out here on a line. It will be less than negative 12.5, between negative 12.5 and 5, and when x is greater than 5. So moving forward, we set this up into an interval chart. We have the intervals here on top. That's why it's called an interval chart, and also because the lines are here, that's what makes it a chart. And along this side we have the terms, and a final row will be the sign. So we plug in a number that is less than negative 12.5, and when we plug it in here it's negative. 5 will always be positive, as you can see all along here, and x minus 5, in this case will be negative. And we go across, you just do the same thing. You plug in a number that satisfies this interval into here where the x is, and so you get positive, and then the negative will be a negative. Here that's a negative, and a negative will be a positive, and here all positives lead to a positive at the end. So we said that the intervals that satisfy this inequality will be the solution. So anything greater than 0 will be the solution. So this positive interval and this positive interval. So in the end, x plus 2 over x minus 5 is greater than 3 over 5 when x is less than negative 12.5 and when x is greater than 5.
So to check our solution, like we said, we will use this graph.
And we have it written out already. On the left side of the vertical asymptote will be negative, on the right side it will be positive, and then we found the end behaviors. And so by looking at this, we see the shaded areas greater than 0, it will be less than negative 12.5, and when x is greater than 5. Thank you for your time. This has been Luke and Spencer.
Thank you.
For a math culminating task. Goodbye.